Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the third question from the St. Stithian Girls College preliminary exam which was written in the year of 2023. Please do expect a total number of 11 videos since the question paper had 11 questions in total. And that simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and most importantly, your final examination. So please guys, do share the video to your peers so that they may have the same edge as you, and please do help us grow the channel by just subscribing. Okay, we are given f of x guys, ne? We are supposed to find the derivative of f from first principle. Okay, we do have an equation we use guys to find the derivative from first principle. Ne? It simply says the derivative of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Are you together? How can I find f of x plus h? I'll simply use f of x to find f of x plus h. Né? This simply means whenever I come across x, I will just substitute x plus h. So I'll keep on writing limit as h approaches 0 of 5 multiplied by x plus h minus x plus h all squared minus f of x. Remember that guys, f of x was given to us as 5x minus x squared. As 5x minus x squared, right? This entire thing is just divided by h. The whole entire purpose, guys, of finding the derivative from first principle is to just substitute 0 whenever we come across h. Are we together? But right now we cannot do that because we will simply have 0 at our denominator, and if the denominator is equal to 0, that means the entire expression will be undefined. So we must try by all means necessary to remove this guy over there. Okay, I have limit as h approaches 0. Let's just remove these brackets, guys. We'll end up having 5x plus 5h, 5x plus 5h minus x squared minus 2xh minus h squared. Then I'll simply have a negative 5x plus x squared all over h. This will simply subtract with that, and then this will also subtract with that one. So I'll be left with limit as h approaches 0 of 5h minus 2xh minus h squared all over h. I can then take out a common factor there at the top, which is h. I'll end up having 5 minus 2x minus h all over h. And then these two will simply cancel one another, and then I'll be left with limit as h approaches 0 of 5 minus 2x minus h. Now guys, I can simply substitute h as 0 because nothing will be undefined if I do so. So I'll end up having 5 minus 2x minus 0. Please note that guys, whenever I'm substituting h with 0, whenever I'm substituting h with 0, I no longer write limit as h approaches 0, because this statement or this notation is the one that kept on reminding me that I should substitute 0 whenever I come across h. So whenever I'm doing that, I don't have to keep on reminding myself. Are you together? So whenever you substitute the 0, please do not write this notation. And then your final answer, guys, will simply be 5 minus 2x. This is your derivative. Are you together? Okay, now let's move to the following question. We are supposed to determine the derivative of y with respect to x if y is equal to that over there. Né? So y is equal to 6 over the cube root of x minus x squared plus 5 all over x. Okay, now guys, we are not told to find the derivative by using first principle or whatsoever. So that means we are supposed to use the rule. Now remember that guys, if f of x is equal to a multiplied by x to the n. Therefore, the derivative will simply be n multiplied by a, and then x, I just need to subtract 1 from my exponent. Are you together? So this is the rule I'm supposed to use for me to find the derivative. But before I do that, guys, I need to make sure that the variable I'm supposed to derive, I'm deriving with respect to x. So I need to check, is x inside the bracket? If x is inside the bracket, I need to remove that x inside of the bracket. If x is at the denominator, I need to remove that x at the denominator. If x is in surd form, I need to remove x inside the surd. Are you together? Over here, I do have my x value in surd form and there at the denominator. Okay, so how can I remove the x in surd form? Remember that, guys, from your surds, there is a rule that simply says the root of a number is always the denominator of your exponent. So a will just be the denominator of our exponent. So over here we'll simply have 6 all over x to the power 1 over 3 minus, are you together? The x, guys, is just dividing the two numbers, so I'll end up having x squared divided by x plus 5 divided by x. Are we together, guys? Okay, and then obviously, guys, now I want to remove the x at the denominator. How can I do so? There is a rule, guys, from your exponent that simply says if ever you have c all over a to the power p, this can be written as c multiplied by a to the power of negative p. Are you together? So for you to remove a number from the denominator to the numerator, all you have to do is to just change its exponent. So I'll end up having y is equal to 6 multiplied by x to the power of negative 1 over 3 minus x squared divided by x is just x, and then plus 5 multiplied by x to the power of negative 1. Now the variable I'm supposed to derive is not in brackets. The variable I'm supposed to derive is no longer in surd form. The variable I'm supposed to derive is no longer at the denominator. I can therefore use my rule to find the derivative. But please note that, guys, whenever I find my derivative, I no longer write y. And I can only write this statement, guys, or this notation, if what comes after the equal sign is my derivative. If I'm not writing the derivative after the equal sign, that means I'm not supposed to write this statement over there. Okay, so the derivative of this term over there is just equal to negative 2x to the power of, when you say negative 1 over 3 minus 1, you'll simply get negative 4 over 3. And then the derivative of negative x is just equal to negative 1. The derivative of positive 5x times of positive 5x to the power of negative 1 will just get negative 5 multiplied by x to the power negative 2. By just doing this, guys, we are done. But if you want to leave your answer in positive exponents, you are more than welcome to do so. We'll end up having dy over dx is equal to negative 2 all over x to the power 4 over 3 minus 1 plus 5 over x squared. You can change this as well into surd form if you want to. So that's how, guys, you're supposed to determine your derivative over there. Okay, and then now, guys, we are told to find the coordinates of the point on the graph of g of x where the gradient of the tangent to the graph is equal to 2. Okay, remember that, guys, the derivative of a curve is always equal to the gradient of a tangent at a specific point. If I have an x value, guys, and whenever I substitute my x value on the derivative, this will give me the gradient of my tangent. Are you together? But if I substitute the x value on the function, this will give me the function value, or can say the y value. Are you together? So now I have the gradient, guys. So if ever I take the gradient of my tangent equated to the derivative, this will give me an x value. After finding that x value, I can substitute it on the graph of G to find the corresponding y value, and that will be the coordinate. Let's just do so. Firstly, let's find the derivative of G. G prime of x will simply be equal to negative 8x minus 6. I'm deriving my equation over there. Now, I'm told that the gradient of a tangent to the curve is equal to 2. So I want to know what is the value of x if the derivative is equal to 2. I'll simply have negative 8x minus 6 being equal to 2, which is my gradient, right? And then this will just give me negative 8x is equal to a positive 8, and then x is just equal to negative 1. So I now know that when x is equal to 1, the gradient of a tangent is equal to 2. Now I know the x value. For me to find the corresponding y value, I just need to substitute the x value on the original graph. So I'm looking for g of negative 1. That's just negative 4 multiplied by 1 squared minus 6 minus 1 plus 1. And then this will just give me 1 plus 6 is 7 minus 4, that's 3. So the coordinate, guys, whereby the tangent is in contact with the curve, it's just negative 1 and 3. At this point, guys, the derivative, or rather the derivative of my curve, g prime of x, will be equal to 2 at this point only. So, but you're only asked to find the coordinate, guys. By simply writing this, you are done. Get your 5 marks and go home. That's how, guys, we're supposed to tackle this question over there. So please, guys, do stay tuned and wait for more videos. Thank you for your time.